We covered Lambda syntax quite a bit in Lesson 4-2. That means in Lesson 4-3, we can jump right into the lab. I'll give some tips which you might find helpful to finish the lab, and wrap up with some closing thoughts. Lab 4 instructions are available on the Lesson 4 page of the MOOC. This is an enhanced version of the program you wrote in Lab 3. The application is designed to work with many account instances. It's also a GUI app, GUI meaning Graphical User Interface. To make this application visual, it's written in JavaFX, just like Java Puzzle Ball. Lambda expressions detect button presses, and Lambda expressions implement the logic and functionality of working with bank accounts when these buttons are pressed. I can demo this for you. So let's go to run the application. You'll notice right away when you go to run it, there's some text in the output. I can't really see it all that well. So I'm going to double click right here to maximize the window. Okay, now we can take a look at all the accounts. This is the collection of accounts we'll be working with in this lab. Alright, so let's play around with the application. So let's say I have account 5, and what I want to do on account 5 is make a deposit of 200. Okay, and then we see on the printout we've deposited 200. Can I withdraw 200? No, I can't. I don't like that. I'm going to close my account. So some of these buttons work, some of them don't. Your goal for Lab 4 is to implement the code for any button that isn't working yet. When you start exploring the code, there's a few things you'll notice. One is the new FX main class. This replaces test class from Lab 3. It still contains the main method, but it has other special components which are necessary to launch a JavaFX GUI application. It also creates many account instances. The collection of these accounts is stored in an array list. An array list is a special kind of class in Java, and because both checking and savings account classes inherit from the abstract account class, this array list of accounts may contain both checking and savings accounts. But you won't need to do any work in new FX main. You'll only need to do work in the button controller class. The field variable account list stores the array list of accounts. When you start implementing button functionality, account list is what you'll need to create a stream of and filter. Remember back in Lab 3 where you'd create and manipulate bank account instances from the main method? It's a little different this time. Normally, you'd first create a new instance of an object and give it a name, like savings1. This name becomes the reference variable for that object, and you can use that reference variable to call the object's fields and methods. In Lab 4, the stream creates the reference variable for you. In this stream, A is a reference variable which is used to represent any given account instance. And we know what kind of object A is because we've specified that this array list is an array list of accounts. Once you have your reference variable, you use the dot operator to attempt to access the instance's fields and methods. For example, to access a field, you might do a.accountNumber. To access a method, you may do a.deposit. But you'll notice in this example, we're not actually referencing the account number field by calling a.accountNumber. We're instead calling the method getAccountNumber. The reason why we're doing this? It's dangerous to allow different classes to freely access and edit each other's fields. A design pattern known as encapsulation makes fields private or protected, preventing other classes from accessing or modifying fields in an unsafe way. Instead of accessing a field directly, you want to use specially written getter methods to read the values of a field, and use setter methods to change the value of a field safely. You can think of deposit and withdrawal as setters. They prevent negative or inappropriate values from changing the account balance field in an unsafe way. In the case of an account number, we don't want that value to ever change, which means we create a getter method to read the value of that field, but the setter is private. We don't want other classes to call any method that could change the value of the account number field. So check out the account class. You won't need to make any edits, but all the getters and setter methods you'll need for Lab 4 are in this class. These methods are shared by all checking and savings accounts, and there are some extra fields and methods that you didn't see in Lab 3, like transactions and reset transactions. And really, the only special situation is with button 6. It does something called casting to access the earn interest method. It has to do this because this method is exclusive to the savings account subclass. The syntax is a bit messy, but you won't need to do any casting for this lab. So just a couple more things worth mentioning. When you filter, you'll need to compare values. For reasons beyond the scope of this course, using equals equals on text, known as strings, is not recommended because you might get the wrong result. This has to do with how Java stores strings in memory. Instead, when you're working with strings, use the .equals method. That's what's going on in the button 3 pressed method. Although here, we're getting the input from the account number field and treating that like it's a string. When you do compare numbers, you have a lot more choices in logic operators. You've seen equals equals and not equals, but you can also incorporate greater than or less than into your logic. And to help organize your logic, you could use parentheses. Just be careful that the parentheses match the way you think they do. It's easy to mismatch, forget, or add an extra parenthesis somewhere. And finally, you'll need to do a little functional programming. When you see the same lambda logic repeated, this is an indication that it may be beneficial to store the repeated logic as a variable. You've seen consumer lambda expressions. Lab4 uses 2 predicate lambda expressions. Your assignment is to identify where logic is repeated in the button controller class and replace the null value of the 2 predicate field variables with that lambda logic. That's it for Lab 4, and that brings us to the end of the course. I hope you've enjoyed it and enjoyed playing Java Puzzle Ball. I've wanted to make a course like this for a while, in part because I wanted to break away from the usual corporatism, which is where the weird characters and scenarios came from, but more importantly, I wanted to get this game out there for people to play, and I wanted to show what implementing this game-based learning methodology looks like and the benefits of learning through play, learning through exploration. I'd love to do more cool stuff like this, so if you've enjoyed my design work and want to help convince the powers that be, feel free to leave a message on the forum or shoot a message to the mailing list, or tell your friends about the game or the course so they can join the fun too. If you'd like to continue learning, I wrote a section in Oracle Academy Java Foundations about creating JavaFX applications. There's a lot of creativity that went into the Java Foundations course, and in general, Oracle Academy does some pretty cool stuff. Oracle University covers Lambda expressions in Java SE 8 new features. Their Java Workforce Development program covers Java fundamentals and cloud topics. You could also continue studying with Oracle University and eventually try for their industry-recognized certification exams. And of course, there are courses here on the Oracle Learning Library on Lambda expressions and Oracle Cloud Technology. Thank you everyone for playing Java Puzzle Ball. My name is Nick, game designer and senior curriculum developer at Oracle.